So this is GATE Computer Science 1999 question on TRC, Tuple Relational Calculus. The question is saying that the relational algebra expression equivalent to the following tuple relational calculus expression. So this expression is given to you. First of all, you tell me, is this a TRC1 or TRC2? Is this like TRC1 or TRC2? Like way one of writing TRC expression or way two of writing TRC expression? This is way one, right? Why? What the reason? What is the reason this is TRC1? So you can clearly see, first of all, this is a TRC1 expression. So this is the TRC1 expression because of this, because here we are saying T belongs to R, right? Yes or no? So we are saying T belongs to R. So there is a table R. You have a table R. Clearly, this table R, it has attributes A, B. Okay, yes or no? So there are some like these attributes you have. There can be some other attributes. I don't care. Okay, there may be some other attributes, but this is your table R, A, B, and so on. Now, what you have? You want those tuples. Remember, you want those tuples. So basically, what I am saying that you want those tuples. You want those tuples, okay, which belong to R. Yes or no? You want those tuples which belong to R. Which belong to R. Okay, correct. So you want those tuples which belong to R. Like those tuples we want. We want this tuple. We want this tuple. Okay, we want this tuple. So we want those tuples which belong to R. Okay, and what should happen? And what should happen in this tuple? For example, this tuple will come to the output, and what should happen? And what should happen? You can notice this and. Okay, so this and is also there. So you can notice that this and we also have here. So I can say this and also we have here. Okay, this and you can see. Okay, this and also we have here, right? Okay, so this is the and after that we are saying that the in this tuple the A value must be 10, B value must be 20. Okay, in this tuple, okay, where and in this tuple, and in this tuple, what should happen? In this tuple, A value must be 10 and B value must be 20. And B value must be 20. Okay, so remember, A value must be 10, B value must be 20. Then this will go into the output. A value must be 10, B value must be 20. This will go into the output. If you have this type of situation, this will not go into the output. Okay, this will not belong to the output. So finally, the answer is what? The answer is, okay, the answer will be the answer will be this. I can say that, okay, your answer, one answer is this. What you can say? You can say A comma, you select those where A is 10 and B is 20. Okay, either you select those where A is 10 and B is 20 from R. Okay, so this is your answer. This is one possible answer, right? This is one possible answer. So we don't have this in the options. So what should be the answer? You can notice this should be the answer, because you can select where A value is 10, you can select where B value is 20, and you can take their intersection. Yes or no? Correct. You can select where A value is 10, where A value is 10. You can select where B value is 20. So here A value is 10, here B value is 20. So in the intersection, you will have A value 10, B value 20. So your answer will be option C. Okay, correct. In this question, is this question clear? Your answer will be option C. Now tell me, okay, this is fine. So we got our answer. Now let's see the analysis of option A. What will be TRC for option A? For option A, what will be TRC? If I give you this relational algebra expression I give you, then what will be corresponding TRC expression? Like I give you sigma where A equal to 10 or B equal to 20. Either A must be 10 or B equal to 20 in this R. So what will be the TRC in way 1, way 2, both of them? Here it does not matter much, correct? Yes or no? So you can notice way 1, or I can call it, okay, because we are calling it TRC1. So let's call it way 1, or okay, anyway, or you can call it TRC1. That is what we are calling it. Okay, so what is way 1? Way 1 is very simple. That is basically what you do. You in this relation R, you have these things you have. So in this relation R, what you do? You define a tuple variable, right? Yes or no? You define a tuple variable T. So what you do? And finally, we want the complete tuple. Yes or no? We want the complete tuple. This complete tuple we want in the output. So this is what we in the output. And you can notice what this is saying. This is saying that either A must be 10 or B must be 20. Either A must be 10. This is fine. This is also in the output. This also will go to the output. So either A must be 10 or B must be 20. So the whole tuple we will put in the output. Okay, such that what should happen? This T should belong to R. Okay, this T should belong to R, and what should happen? And what should happen? This should happen that T of A, this should be 10. Okay, or T of B, this should be 20. T of A should be 10 or T of B should be 20. This is your answer. Okay, very simple. What is the TRC2 for the same question? What is the TRC2? The TRC2 is also very simple. So in the TRC2, what you will do? For the result, you will define the tuple variable, correct? For the result, remember, for the result, what is your result? In result also you have A, B, and so on. These things you have in the result. But in the result, you have, like, for example, this is in the result, this is in the result, this is in the result. Okay, this is in the result. Okay, so these things you have in the result, like yes or no. So basically, tuple variable you will define for the result. For the result, you will define the tuple variable. Okay, for the result, you will define the tuple variable. Tell me. Okay, if this is coming, then what should happen? Then there should exist a row as it is. Agree or not? Yes or no? Okay, if this is coming in the output, if this is coming in the result, this is what I'm saying. If this is coming in the result, then there should be tuple here. Okay, there exists a tuple here. There exists a tuple here, such that x is equal to t. Such that x is equal to t. Yes or no? Yes or no? So I can say that there exists a tuple in R. There exists a tuple in R, such that what should happen? What should happen? This should happen that this x must be exactly same as t. This x must be exactly same as t. They must be same. Yes or no? They must be exactly same. And what should happen? And what should happen? Tell me. And what should happen? This should happen that x dot A is equal to 10 or x dot B is equal to 20. This is the way of writing the same query, the TRC query. Is this clear? Tell me, how many of you got this answer? How many of you got this answer? Tell me. How many of you got this answer? Okay. In this question, can you notice this will be wrong? If I remove this, it will be wrong. Can you notice? Now this will be wrong. If I do this, that x belongs to R. X belongs to R. If I do this, x belongs to R. And if I do this, now this will be wrong. Why? Tell me why this is wrong. What is the reason? Because I told you the only free variable must be this. This should be the only free variable. Agree? This should be the only free variable. This we have already seen in the class. In the lectures, we have already seen. This should be the only free variable. So this cannot be free variable. Yes or no? This cannot be free. This cannot be free. Agree? Okay. This cannot be free. This cannot be free. So that is the reason this is wrong. That is the reason this is a wrong. Okay. That is the reason this is wrong. Is this clear? Tell me yes or no. Because remember, the only free variable must appear on the LHS. This I told you in the TRC query. This we have already seen in the TRC query. Note that, okay, whatever TRC query you take, whatever TRC query you take, whatever, way 1, way 2, okay, whether you have TRC1, TRC2, whatever TRC query you take, this LHS, let's call it LHS and let's call it RHS. So what should happen? In this LHS, you have, okay, only free variables can be here. Only and all free variables. Yes or no? Only and all free variables. Agree? So only and all free variables. So here you must have only free variables and all free variables. Okay, so here everything is free. Here everything is a free variable and every free variable is here. Okay, here every variable is free and every free variable is here. So remember these two statements. Here every variable is free and every free variable is here. Okay, this is the RHS, and here you can say, here you have all variables. Here you have all variables. But remember, the remaining variables must be bounded. Remember, the remaining variables must be bounded. The remaining variables must be bounded. Must be bounded. Okay, the variables which are not on LHS, they must be bounded. Is this clear? Mavit is saying, is there any reason for this? There is a very obvious reason. What is the obvious reason? Because if you have free variable, then basically you cannot say true or false if you have free variable. See, if you have free variable here, which is not here, then you cannot say true or false. Okay, what is the reason? Let's understand this. Let's see this example. Consider this example I am giving you. Like, let's assume the domain is set of real numbers. Let's assume the domain maybe set of natural numbers. You can take the domain. Okay. So when I say domain is set of natural number, it means what? It means every variable is here. Yes or no? It means every variable is here. It means every variable points to this domain. So this is the domain. Now, if I give you this statement, consider this statement that for all y, x must be less than equal to y. Okay. Now consider this statement. Look at this statement. Tell me what is the bounded variable here? What is the bounded variable here? Here bounded variable is y. If you notice the bounded variable, that is y. And what is free variable? What is free variable? That is x, right? Okay, free variable is x. Tell me, can you say true, comma false here? Can you say this is proposition? Is this a proposition? Is this a true or false statement? Is this a proposition? The answer is no. Yes or no? The answer is no. This is not a proposition. Definitely this is not an answer. No. Why? What is the reason? Okay, why? What is the reason? Because there exists a free variable. Because there is a free variable. Because there is a free variable. So because there is a free variable, so the answer will be no. Now you notice what will happen. So, but I can say because there is a free variable, so its answer will be in terms of free variable. Actually, if you notice, what answer will you give here? Just tell me. Here, what answer you will give me? Here, what your answer will be? Your answer will be in terms of free variable. Agree or not? Your answer will be in terms of free variable. Your answer will be in terms of free variable. I can say your answer will be those values of free variable which satisfy this. Those values, okay, of free variable which satisfy this. Free variable which satisfy this. Which satisfy this. Correct? Which satisfy this. Let's call it S. Let me call it S. Okay, so I can say which satisfy this S. Agree or not? Tell me, is this clear or not? Very simple. Okay, so this is a very simple point. So you can notice here, if you notice the answer will be in terms of free variable. Tell me what your answer will be. Tell me what your answer will be. So in this situation, what your answer will be? What your answer will be? The only possible answer is actually x equal to 1. Correct or not? The only possible answer is x equal to 1. Agree? The only possible answer here is x equal to 1. Yes or no? X equal to 1 is the only possible answer. N is equal to 1, 2, and so on. So x equal to 1 is the only possible answer. Basically, if I write like this, just think about it. X which satisfy this. X which satisfy this. Tell me what is this set? Tell me what is this set? What is this set? This set is this. Agree or not? Now did you understand this? Please tell me. Now did you understand this? What is happening here? Okay, so the same thing is happening in the TRC. The same thing is happening in the TRC. In the TRC also the same thing is happening. You can notice this is free. Okay, so the same thing is happening in the TRC. Exactly same thing happening in TRC. Exactly same thing in TRC. In TRC also exactly same thing. In TRC we want those. So this is free. Okay, this is a free. This is free tuple variable. This is free tuple variable. And basically we are saying that give me those tuple variables, or I can say give me those tuples where some expression you have. Now here you can have t also, and here you can have some other variables also. Some other variables, x, y, z, some other variables. Now they must be bounded. Agree or not? They must be bounded. Now again the simple question, why they must be bounded? Just think about it. If I give you this statement, why they must be bounded? Just think about it. If I give you this statement for all x, here you can say that, here you can say answer will be this. Agree? Okay, here you can say answer will be this. But. Now if I put one free variable here, another free variable here, x must be, if I put another free variable here, some other free variable I put here. Now you cannot give the answer, right? Yes or no? Now you cannot give the answer. Basically you are saying that free variable which will satisfy this. Yes or no? Free variable which will satisfy this. Okay, values of x which will satisfy this. Now here you cannot, okay, you cannot determine the answer. Answer cannot be determined. Yes or no? Cannot be determined. Cannot be determined. So we cannot determine the answer. Is this clear? because we need the value of z also. So this z must be bounded. This z must be bounded. Agree or not? This z must be bounded. So here I cannot determine this, but if I make it bounded, it will become determined. Okay, I can determine this. Like if I make it bounded, for example, if I put there exists z, now tell me what will be the answer. Now tell me what will be the answer. There exists z, such that this should happen. Such that this should happen. Now the answer again will be 1. Now the answer again will be 1. Okay, remember the domain is domain. Remember the domain is set of natural numbers. The domain is set of natural number. The domain, consider the domain. Mavit, is this clear? Is this clear? The domain is set of natural number. So here your answer will be 1. Only this will satisfy. Okay, and now what your answer will be? If I say for all z, if I say for all z, for all y, now what will be the answer? For all z, for all y. Now what is going to be the answer? Now the answer will be empty set. No, nothing will satisfy this. Nothing will satisfy this. Yes or no? Nothing is going to satisfy this condition. No number is going to satisfy this condition. This one will also not satisfy this condition. This one will also not satisfy this condition, because you are saying for all z, for all y. Okay, basically you are saying this. You are saying that whatever you put here, whatever you put here. You are saying this, whatever natural number you put here, whatever natural number you put here. Is that true? Is that true? Is there any number? Is there any natural number? Do we have any natural number such that you can put any natural number here and such that you can put any natural number here? There is no such number. Agree or not? There is no such number, no such x, no such x. So is this clear to everyone? Mavit, is your doubt clear? So tell me, is your doubt clear that whatever TRC query you take, what should happen? On the LHS, you must have all and only free variables, and all remaining variables must be bounded. All the remaining variables must be bounded. Is your doubt clear? Okay, Mavit is saying crystal clear. Anyone else? Is this crystal clear? Tell me. See, these are the concepts we have already seen in the first order logic. All these concepts we have already seen in the first order logic. All these concepts, every concept, we have already seen in the first order logic. What is a free variable? What is a bounded variable? When your predicate will become proposition. So you can notice this is not a proposition because there is a free variable. If there is a free variable, then that is not a proposition. But if I give you this is not a proposition, but the answer will be in terms of free variable. I can say x equal to 1 will satisfy. Yes or no? I can say x equal to 1 will satisfy. Okay, something like this. So another question I can give you, for example, the same thing. I can also say that now who will satisfy? Tell me. Now who will satisfy? Like if I say that y greater than equal to y greater than 3. Okay, now tell me, now what will be the answer? Now what is going to be the answer? Who will satisfy this? Where y is greater than 3. For all y greater than 3, this would happen. For all y greater than 3, this would happen. Now your answer will be what? Now your answer will be very good. That will be 1, 2, 3. Yes or no? 1, 2, 3, 4. 1, 2, 3, 4. Yes or no? 1, 2, 3, 4. Correct. So your answer here, your answer will be 1, 2, 3, 4. Because for all y greater than 3, this would happen. So you cannot, this set is equal to this set. Okay. So crystal clear, all these points, see one by one, all the points. So you can notice whatever TRC query you have, on LHS, you must have only and all free variables. On RHS, all variables you will have, but the remaining variables must be bounded. The remaining variables must be bounded. This is the conclusion. Okay, this is the conclusion of TRC. So you can notice this is wrong. Yes or no? So if I write like this, x belonging to R, if I directly write this will be wrong because this cannot be free. Okay. So this is the question. Now option A we have seen. So for option A we have seen. What about option B? Can you write the TRC query for option B? We have already done that. Can you write TRC query for option B? For union we have already written. For union and for set difference we have already written. So okay, tell me for which. Let me write for option B. For option B, let me write, or maybe for option D. Let me write option D. You can write for the remaining. I am writing for option D. Okay. So let me write option D. What is the option D? If you look at option D, this is what it is saying that where a equal to 10, those tuples, minus where b equal to 20, those tuples. Okay, so this is a set difference. Can you write the TRC query? Okay, let's see TRC first way. One way of, okay, what is the TRC query? The first way, where will you take the tuple? Where will you take the tuple? You will take the tuple in which? In R, yes or no? T belonging to R. So in this relation R, so there is A, there is B, and so on. Okay, so what you will do? So T belonging to R, T must belong to R. You must take a tuple variable T which belongs to R. And what should happen? When will I put this in the output? This tuple, when I will put this in the output, this tuple, when I will put this in the output. So this is saying that those tuples which have A value 10 minus those tuples which have B value 20. Those tuples which have A value 10. Here you have those tuples which have A value 10. Remember those tuples which have A value 10. From these you are removing those tuples where B value is 20. Okay, from these tuples you are removing where B value is 20. So I can say those tuples we want where A value is 10 and B value is not 20. Agree or not? We want those tuples. Ultimately, we want those tuples where A value is 10, where A value is 10 and B value is not 20. Correct? Is this clear to everyone? I want those tuples. I want those tuples. Remember, I want those tuples. So this tuple I want where A value must be 10 and B value must not be 20. Okay, this tuple will be in the output. I want this tuple in the output. So I can say this tuple variable T you take, and very simple thing you have to check actually. Very simple thing you have to check that T of A must be 10 and T of B must not be 20. Must not be 20. T of A must be 10, T of B must not be 20. This is your tuple variable TRC. Yes or no? Okay, you don't have to take any other variable. Single tuple is all we have to check. We have to check single tuple. Single tuple we need to check, yes or no? Single tuple needs to be checked. Correct? We need to check a single tuple. Only single tuple we have to check, because remember what this is saying. This is saying those tuples which have A value 10 minus those tuples which have B value 20. So from those tuples which have A value 10, you need to remove those tuples where B value is 20. Is this clear to everyone? Please tell me. So ultimately I want those tuples, okay, which are in R where A value is 10, B value is not 20. Tell me, did you get it? Did you get it? Tell me. Okay, so the same question, can you write the TRC2? For the same question, can you write TRC2? Remember, the result will be same as the schema. The schema will be same as schema of R. So the result will be like this. In the result, you have those tuples which have value 10 here. So this tuple will be in the output. This tuple will be in the output. This tuple will be in the output. So these tuples will be in the output. You can notice. Okay, these tuples will be in the output. So these tuples are going to be in the output. So I can say that I will create a T variable here in the result. In the result, I will create a T variable and I will say that this T must be exactly same as this tuple. This tuple, I can say, when I can say this tuple will come in the result? Tell me, when can I say this tuple will come in the result? So when can I say this tuple will be in the result? This tuple will be in the result. Okay, if this belongs to R, as it is, this should belong to R. Yes or no? This tuple will be in the result if there exists a tuple in R which is exactly same as this. Correct? There exists a tuple in R. There exists a tuple in R which is exactly same as this. Which is exactly same as this. Okay, so I can say there exists a tuple in R which is exactly same as this. X equal to T. And what should happen? And what should happen? XA is equal to 10 and XB is not equal to 20. Correct? And XB is not equal to 20. Yes or no? Correct? This is your answer. Tell me, did you get it? See, very simple, right? Okay, so this is very simple answer. So this will be your TRC2 query. I can say this is the way to. So I want those tuples. I want those tuples. This tuple must exactly belong to, okay, this tuple must as it is. This tuple in the result, this must be as it is in the relation R. Okay, there exists a tuple in the relation R which is as it is same as this. And what should happen? You can notice XA must be 10 and XB must not be 20. This is your option D. Is this clear? Similarly, can you write for option C? For option B, For option B, what you will write? For option B, intersection. Your option B was, I think that was intersection. What was your option B? Union. Okay, option B was union. So tell me, for union, how will you write this? The same question for option B, that was union. Okay, you are doing the union of these two. So basically those tuples we want where either this is 10, okay, this can be anything, or this is 20, this can be anything. Okay, either this is 10, this can be anything. So here in the same question, I can say those tuples I want where this is 10 or this can be anything. Okay, I can say this is equal to 20 or this is equal to 20. This is your TRC1 for option B. And for option B, what will be TRC2? For option B, what will be TRC2? Basically, I want those tuples where I have 10, then I don't care what is here. And if I have 20 here, then I don't care what is here. If I have 20 here, I don't care what is here. Okay, so these type of tuples I want. These type of tuples I want. I want these type of tuples. So what I can do? Very simple. There exists a tuple which is as it is same as this, x equal to 10 or xb equal to 20. Okay, either this would happen or this would happen. This you can put as a in a bracket. This you can put in a bracket. That okay, x that should be same as t. That should be same as t, and xa must be 10 or xb must be 20. So like this, we have done the complete analysis of this question. Did you understand this? Tell me. This question, did you understand? For every option, we have written the TRC query. For every option, we have seen what is the TRC query for every option. Okay. And we have seen the correct answer will be option C. And yeah. Okay. So this is the complete analysis of this GATE question.